Okay, we are very fortunate today to have Xavier Franch as our speaker. He is a full professor at the Polytechnic University of Catalonia in Barcelona, Spain. He is the leader of a service and software engineering research group, about 15 academic members, postdocs, and PhDs. He has a long publication track with more than 200 papers published and over 4,500 citations for these. He's a member of several editorial boards of major journals. He belongs to the steering committee of the IEEE Requirements Engineering and other conferences. He's also a member with me of the International Software Engineering Research Network and a council member of something called the International Requirements Engineering Board, that is the major requirements engineering certification provider worldwide. So I've interacted with Xavi for several years. He's been working in this field for over 20 years, particularly in software quality and non-functional requirements. Actually, his PhD thesis, which he did in 1996, he proposed a language to state non-functional requirements in modular Ada-like programs, and he called it NoFun, arguably about the best possible name for such a language. So this language really sort of looks very similar as a predecessor of service-level agreements for service-oriented computing. Since then, he's been a principal investigator of several European Community and other science programs, and always with non-functional requirements in focus. So currently, he's the coordinator of the Q-Rapids project in the Horizon European Union 2020 European Union program, and we'll speak about that project during the talk. He's doing a similar thing on another European program that is looking at managing language requirements. So again, these involve not just universities, but big European Union players like Nokia and Siemens, and other companies in the Agile business. So again, what he's looking at is very similar to what the SERC is doing for the U.S. Defense Department, which is saying, how do you get high quality at rapid speed? So Xavier, looking forward to your talk.
Thank you so much, Barry, for the introduction, and good morning, good afternoon, good evening to everyone. It is exciting to be here with this wide audience. So, this is the title of my talk, Why Are Ontologies and Languages for Software Quality Increasingly Important? I think you all have access to the slides, and this is the outline of the presentation that I will give to you. So first I will motivate a bit the topic, and then I will enter into the main part of the presentation that is focused on ontologies. And since we want to apply ontologies to software quality, I will talk about quality models as a particular way to implement ontologies, and I will pay attention on how they are used in practice nowadays. Then I will devote some time to a particular point that is crucial in the use of any type of ontology or quality model, that is the customization to a particular context. And after some general methodology, I will provide one example first that is related to this Q-Rapids project that Barry just mentioned, and a second example about requirement patterns. And then I will target the last part of the talk, that is expressing ontologies in some language, and I will give as example one well-consolidated language in our requirements engineering community that is called the NFR Framework. I hope to be able to cover all the topics. In any case, if I need to skip some, the slides are quite complete, and you can contact me afterwards for any clarification. So again, this is the title. So let's go to see why we need ontologies and why we need languages for software quality. But in fact, the first question could be, why is software quality increasingly important? And here I have been fortunate that I do not need to motivate much, because we had one excellent talk in this seminar series, in these talks given by Bill Curtis in this last October. Well, he really covered the topic of software quality and also relation to artificial intelligence. And he made an excellent motivation. And I just want to refresh for those of you that were there, or to invite you to share for those of you that were not there, one particular sentence that he gave in one of the slides. First, he questioned the old way in which quality was considered. The old definitions that say that this is the degree to which a product meets the specified requirements. And he gave some detailed why that you can go through in his presentation that is also recorded. And he mentioned two very important problems that are central also to my presentation. First of all, customers struggle to state functional requirements. But given that this is something difficult, what is more shocking is that they do not understand what is a non-functional requirement. Sometimes they have difficulties in giving a clear definition of what are the type of non-functional requirements that they need to handle and how to express them. And in fact, he mentioned, he quoted some sentence appearing in the book that you can see in the slide called Quality, that justifies or motivates the need to improve the state of the art in software quality and non-functional requirements. A failure to satisfy the non-functional requirement can be critical, even catastrophic. Again, this is something that Bill went through quite in detail in his talk, so I refer to the video of this presentation. But again, if I take this sentence that appears here, they do not understand non-functional requirements, this links very well to one very old and well-known problem. Since, for instance, 1996, in which one quite cited paper by Barbara Kitchenham and Shari Lawrence Flieger, entitled Software Quality, the Elusive Target, made the point about this difficulty to manage quality requirements from different perspectives. First, quality requirements are difficult to specify. Inherently, they are concepts that are not as easy as to describe a function of the system. Furthermore, they are difficult to quantify. If we want to express efficiency, reliability, security, how can we make this general aspect concrete in some particular thresholds that need to be accomplished in order to satisfy the main goals? And then they are difficult to verify compared to functional requirements, for which there are a lot of techniques that emphasize how to design test suites. Functional requirements are more difficult, and not only difficult, but they are quite diverse if we talk about efficiency, if we talk about reliability, if we talk about usability. They are fundamentally different, and they require different ways to be approached. But even before all of these elusiveness characteristics, the most striking assertion is that they are difficult to agree upon. And they are somehow, this is somehow the root of the difficulties that I was mentioning before. If we are not agreeing on what is a non-functional requirement or what are different types of non-functional requirements, we may have some difficulties to specify, to quantify, to verify, and to manage them. It is very easy to back up this assertion. For instance, if we take the non-functional requirement concept itself, I just put in this slide some quotations that appear in well-consolidated sources that may be more, let's say, pedagogical, like textbooks, more research-oriented, like PhD dissertation or papers, or even the Wikipedia. So we have highlighted the words that the different authors or the different sources use to describe what is a non-functional requirement. They use property, they use quality, they use aspect, constraint, criteria, physical constraint, external constraints. So we may find a huge variation on the way in which a non-functional requirement is described. And not only the term itself or the concept itself of non-functional requirement, but also if we take, again, some of these and other definitions that we may find, the categories of quality, the types of non-functional requirements are really diverse. So they talk about appearance, speed, accuracy, portability, and so on. We have different words to describe similar concepts like speed, efficiency, performance. They are more or less synonyms, but they are not always synonymous. So you need to go into the details. Maybe these details are not in the sources that you are analyzing, and you need to guess what is the real behavior that is behind that word. All in all, at the end, we have different proposals of catalogs of non-functional requirements that have evolved over the decades. So in the upper part, you have two old ones. Then you may have another that are a bit more modern, 15 years ago, but still they are different. And then you have standards. If you go into the details, that I will not go through, of course, but if you go into the details of these quality models here, and these quality aspects that are described, you will see a lot of resemblances, but a lot of differences. And these differences are the hard part to cope with. So this is the kind of motivation. How can we deal with this diversity? How can we reconcile all these different aspects? How can we arrive to some kind of agreements, to some kind of conventions that we can use when dealing with quality? So to cope with this diversity, we have an old concept that is the one that I'm presenting here in the context of software quality. That is the concept of ontology. And when I say old, I really mean old. For those of you that don't know the concept, probably not many of you, ontology comes from philosophy, from the old times of philosophy, and it is defined in philosophy as a branch which deals especially with the nature of being. Of course, this definition is very abstract, as one may expect to be if we talk about philosophy. And this abstract definition needs to be a bit more concretized in order to make it operational for our, let's say, software engineering or requirements engineering purposes. So this concept is a bit more refined in the NETS definition that is quite popular in our field. That is, an ontology is an explicit specification of a shared conceptualization. So we have, like, every word is a keyword, but there are two that are very important. First, explicit. It is very important that every concept that is behind our system is made explicit. And if we talk about quality, this means that we need to really describe every aspect of quality in an explicit way so that we do not rely in tacit knowledge that can be very different from one person to another. And the second keyword is shared. Ontologies by nature try to capture shared beliefs so that all the individuals that are managing this explicit specification can really agree that the concept that is being described is agreed by all of them. Importantly, in an ontology, we need to have a very well established and unambiguous terminology. This is provided by the ontology themselves, and it is the basis of the description that the ontology is aiming at. I really recommend you, if you have not go into this concept in detail, I really recommend you this paper, A Translation Approach to Portable Ontology Specifications. It's an old paper, 25 years old, but that in some sense has the basis of the understanding of what an ontology can be in computer science in general. If we start to focus a bit on our domain of this course, that could be requirements engineering, there are several types of ontologies, and I'm borrowing here a classification that appears in some other paper that defines three main categories of ontologies in requirement engineering. The first category is to consider ontologies as a means to provide a structure to specification documents. So at the end, as requirements engineers, one of our products is a requirements specification, a requirements document. And in some sense, we need to be able to provide a structure that is agreed, that uses a common terminology, so that an ontology can be used for this purpose. As you can see here, I'm using several references trying to illustrate the different parts of my talk, and I recommend you as an example of this particular category, this reference here from some people that works in the artificial intelligence field, but have made a contribution to this requirements engineering topic. The second type of category of ontologies are the so-called fundamental ontologies. So fundamental ontologies try to go to the, let's say, the core of requirements engineering and try to provide a definition to every concept that is managed in requirements engineering, starting by requirements itself, of course. There is a recent paper that is a state-of-the-art paper based on a systematic literature review, just 2 years ago, was published in the Requirements Engineering Journal, that provides a good survey on what fundamental ontologies have been provided in the field of requirements engineering. And the third main category has to be with the so-called application domain ontologies. This means that in this case, the ontology is designed to cover one particular area or domain of interest. So it's a narrower scope than the two former categories. And for that particular domain, the ontology tries to go into all the aspects that can be behind the domain. So one example that I give in this slide is an ontology for security requirements. So in this example, you will find a well-developed ontology that goes into the details of this particular area. Of course, all these approaches can be combined. So we can rely on a fundamental ontology as a general framework for working with. Then we may have one or more application domain ontologies for the areas in which we are working. And then we may adopt a specification, the structure ontology, in order to express our requirements. Talk about expression. How do we express an ontology at the end? There are a lot of approaches to express an ontology, and I will come back later to this issue at the end of my talk. But now I'm giving just an overview of what are the three main elements that comprise an ontology. First, a lexicon of concepts, a kind of glossary in which the concepts that are part of the domain in which we are working are described in detail as unambiguously as possible. Of course, this degree of ambiguity may depend on the language that is used. If it is natural language, it is well known that we cannot get completely rid of ambiguity. If it is a more formal language, we can express things in a more precise way, but of course, then the difficulty of defining and using the ontology is greater. The second element that comprises an ontology is a taxonomy. All the concepts that have been introduced in this lexicon are arranged into a taxonomical structure. Depending on the author, you may find authors that are quite strict in not allowing a graph-like structure, while others are more permissive. But this is a matter of, let's say, background. And the third component comprising an ontology are the properties among the concepts that form the lexicon. Properties that go beyond the taxonomy. One could consider that taxonomical relationships are a particular type of properties, but then we need to be able to express more general properties that make the ontology more precise and more complete. I have talked about requirements engineering. Now I can talk more precisely about quality, about software quality and about non-functional requirements. There are several approaches to that. And of course, as some of you or most of you may know, Barry Bing, Dr. Barry Bing himself with the team at the at the Southern California University, have worked in this topic in the last years. And while reviewing, if you take a look to the approximation that they have done, you will find a very interesting quotation here. Again, why an ontology for quality is needed. The primary need for a system elitist ontology is to enable more effective collaboration in system definition, development, and evolution across system stakeholders from different disciplines. So if we focus in software quality, we see that we have basically the concept that I have motivated at the beginning and let's say the motivation to finalize with this kind of Babel tower that we have for software quality. Ontologies can be approached in different ways. There are more formal approaches in which a language like description logics can be used, and then we may aim at different reasoning capabilities about quality. But this is not the way in which ontologies are more used in our context. In software quality and in practice, ontologies are taking a lightweight form, that is the well-known and old concept of quality model. Maybe you have not reflected about the relationship between these two concepts, but in fact, a quality model is no more than a lightweight implementation of an ontology. If we take, for instance, the ISO definition of a quality model, it is as this quotation, the set of characteristics and the relationships between them which provide the basis for specifying quality requirements and evaluating quality. Therefore, we can say that the characteristics that are mentioned in this definition or the quality attributes are the terms that form the ontology, and the relationships that are also mentioned in this definition are the taxonomic decomposition that we have in our definition of ontology. Therefore, if we take the detail of one example of software quality standard definition, for instance, the ISO 25010 standard that probably most of you know, we have the three elements. We have the terms, for instance, this is just the 8 characteristics definition of the standard. We have the taxonomy. In this case, this is a tree-like taxonomy. And then we have the properties. For the properties, here I'm presenting the properties with a meta model, a class diagram, which is one of the different ways in which we can express properties. And for instance, there are some properties that can be considered as implied in this diagram, like if we take a look to the part of the subcharacteristics. In this meta model, we are allowing subcharacteristics to be nested. Also, we are allowing attributes to be nested. And also, we are allowing, for instance, that a metric may apply to more than one attribute, and another attribute can be measured with more than one metric, and so on and so forth. I don't enter into the details of this meta model, but what I want to express is that this is a way in which the community that uses the standard may agree on the details that are behind this standard in an unambiguous form. Therefore, if I take again these 3 slides, this can be considered as a lightweight form of an ontology. Again, why it is lightweight? Because it is not really using any formal language that is allowing any formal reasoning behind. One could think about or could wonder about how the community is using quality models nowadays. It is difficult to provide a universal answer because we can find different communities using in different ways. But I would like to present one particular work that we did here in my department with much detail, since we were really interested in knowing what was the state of the art in a particular domain, because we wanted to make a proposal for that domain useful for our tools and projects. This is why we undertook a systematic literature review for the area of web services. As you for sure are aware, this was an area that maybe now not so much, but just 5-6 years ago was still exploiting a lot of concepts. There were a lot of new proposals. And since we were working in a project in this domain, we were struggling with the different approaches that existed at that moment. And we had real problems in understanding how these approaches were compatible, if they were meaning the same when they used the same terms, and to what extent we could combine some of them to provide a unified approach. And I think that we obtained some results that are interesting to share, and this is what I'm going to do in the next slides. Just to provide some context, we made a survey in the period 2001-2013. 2001 was, let's say, the first year in which the concept of web service and service-oriented compute started to be general enough. And after some filtering criteria, we found 65 works that presented 47 different proposals of quality models for web services. These two numbers are different because, of course, one proposal could be presented in more than one paper. Our target were the proposals, so that we made the analysis based on these 47 proposals. Again, just a bit of information. This graphic on the left is showing how these proposals emerged along time. We considered 2-year slot periods, and we saw that there was a kind of curve with the maximum in the period 2009-2010. And then also it is interesting since it was a literature review that most of the proposals were given by academics, and we had very few proposals coming from industry and projects or networks. This does not mean that industries didn't have their own quality models or their own quality concepts, simply that it is more difficult to get access to them. This figure is showing, let's say, the genealogy, and if I can use this name, the nightmare that is behind these numbers. And I think that for our not so rigorous, but more lightweight literature reviews that we have done, this figure is very characteristic of what we can expect to find in some area. So these are all the 47 proposals, or maybe there is a couple of them not here, but I am not sure about that. I have not counted them really. And it shows how there are a lot of proposals that appear without considering former proposals. Are all of them that do not have any predecessor in this graph. We went through all this genealogy with detail, and for instance, we identified that there are 2 seminal quality models, one from the ISO IC 9126 standard at that moment, and then an approach by IBM that was quite used by different other later proposals. But as I said, even with this dominance, up to 56% of the approaches are new proposals that do not rely on any former proposal. They just made some new approach without considering the work that has been done before. This is really inconvenient, of course, because we cannot consider that the community is consolidating with this view. If every new group that is working in a particular topic proposes their own approach. And also, there are a lot of observations that appear in the paper. If you are interested in the topic, I recommend you to take a look. And I'm not going to enter into the details, but also it is interesting to realize how different can be the quality models between them. And we made a kind of relationship between the number of nodes and the number of levels to try to understand if there was a relation, and we found some kind of relation between the two variables. And what we saw is that the nature of these quality models was very context dependent. And this is very important, and I'm coming back to that in 1 second. In fact, literally 1 second, because it is here. This analysis of the state of the art that I'm giving as an example, what shows is that every single use of a quality model is quite conditioned by the context. And there are some studies, and I'm referring here to one of them that has been done by some people here in Europe not far ago, reporting that more than 85% of companies may need customized quality models adapted to their needs. It is interesting to go behind the meaning of this. If I'm proposing the use of ontologies as a way to deal with the diversity of quality concepts, how can we reconcile the shared conceptualization that are behind ontologies with the needs of companies to provide customized quality models? We need to reconcile these two very different forces into concrete methodologies that are effective as to allow this shared understanding, but allowing also to deal with the particularities that every company may have. There are several proposals that have tried to reconcile these two forces. All of them, let's say, take the general picture that I'm presenting in this slide, little by little, as reference. What they propose is that we need to share in a particular domain the most relevant, important, and fundamental concepts of this domain. Considering standards, considering experts, considering literature, all the relevant sources that may influence in this decision. From this analysis, the outcome that we expect is a domain quality model, again, as a kind of lightweight representation of an ontology that is capturing these agreed details of the domain. And from that domain quality model that would represent the common understanding of the community around that domain, we could consider different customizations. So for instance, we have here two different companies, C1, C2, that maybe are working in different businesses. And for company C1, they need to extend the quality model with this blue part, just to go into the details that are not general enough maybe to be in this domain quality model, but are of interest of this company. And on the other hand, they may get rid of some part of the quality model that is not really relevant for their purposes. And in this other context of the company C2, we may have the similar needs, but in different parts of the quality model. So this is the general view that is proposed for customizing to the needs of one particular company while having a shared understanding of the domain. This general picture, as I say, has been treated by many. I can skip this slide very quickly because this slide is just proposing that for building the domain, the model, we need to make a process similar to the one I presented for the web services case. And it is important here to make a decision that may be critical, that is considering for expressing this domain quality model what is an appropriate set of quality characteristics or quality factors. For instance, we could agree, and probably some of you could disagree with this proposal, that we could use the ISO-IC quality model standard. In fact, this is not the relevant thing. Whatever we may consider for the reason that may be pertinent to every domain or to every community, it needs to be an agreed decision that allows the further customization in an easy way. And if we talk about, and we adopt here the jargon of the ISO-IC standard, something that is important is to refine those sub-characteristics that are more relevant to the domain. What does it mean relevant? Let's consider again the example that I gave to you in the web service case. In that paper that I cited, we made this effort that I'm explaining now, that was to analyze these 47 quality models in terms of coverage of the 25010 standard. So that we went through the 8 characteristics to the 47 proposals, and for each characteristic and proposal, we analyzed the coverage that was there. We defined 5 categories. ND means that is not covered. Then we have 2 degrees of coverage, let's say total coverage, and 2 degrees of partial coverage. Total coverage means that, for instance, for functional suitability, there are a 2% of proposal that provide a definition of functional suitability and also elaborate what is inside the concept of functional suitability. While on the contrary, these 2% of functional suitability that are under the Y cell mean that they recognize the need of functional suitability, but they do not give details about how it is done. And similarly, by partial coverage, we had 2 degrees. The partial plus, P plus, means that there is a coverage of some sub-characteristics of functional suitability that is elaborated, and the simple P means that some proposals recognize the need of some functional suitability sub-characteristics. I may agree that it sounds a bit complicated, and probably I will need to explain in more detail, but it's not the real target of my talk. The real target is to see that for a particular domain, like for instance, in this case, web services, we may find that some characteristics are more important than others. Something that is maybe intuitive, but we are here justifying with real data. So for instance, we find that reliability with a 77% of proposals dealing at the highest degree is the most fundamental quality characteristic for web services, while on the contrary, usability, which is not covered by up to 72% of the proposals, is the less important for this domain. And this is relevant information because it's helping you to know where you need to invest efforts in terms of quality to elaborate your proposals. So that we know that for the web service case, we need to focus more on reliability and less in usability. In other domains, it will be other way. We went further to this study, but I will skip this slide. Simply, this slide shows that we went at the level of the sub-characteristics with the green line, meaning that we found some attributes, some sub-characteristics, that were better covered than others, and the red light means them. The main message is that if you want to build an ontology that is useful for a particular area, domain, or community, you need to make sure that you understand the specificities of this area, domain, or community by the proper analysis of literature, standards, and expert opinion. And what we did from this analysis, and that was our real target at the beginning, we defined a consolidated domain quality model for web services. Again, I'm not entering into the details, but what we did is to define the quality attributes that were relevant for the web service domain. And we provided a definition that tried to serve as a consolidation of the definitions that were more popular in the literature that we checked. So this is the first step, and we think that even if it may be time-consuming, you need you need an effort at the beginning in order to provide a domain quality model that can be really used in future endeavors. Once you have this domain quality model, you need to start to customize it to a particular context, and this is the second part of the figure of the picture that I showed before. For customizing a domain quality model, you have several proposals, and I'm presenting here one of them that was published 3 years ago, that is called QAMOCO. QAMOCO is maybe a bit, in some senses, a bit, has a different goal. It's not about ontologies, it's about quality assessment, but at the end, it's based on the definition of quality models, and it's very related to ontologies. And of course, if you need to couple this proposal with the explanation that I gave you just 1 minute ago, you need to make some, let's say, adjustments. For instance, in this QAMOCO, they are using a meta model that is not exactly meta model of the ISO standard. They are more focused on internal quality than on external quality. They emphasize a lot modularity, which is something that I didn't mention before. But anyhow, with a bit of effort, you can put all these two approaches together. So what is the method that is behind QAMOCO? QAMOCO reconciles, on the one hand side, the business priorities of the project or company or area or whatever, so that it is the stakeholders who are guiding you what are the emphasis that you need to put. And on the second hand, they want to use quality models for quality assessment. So they want to have a quality model that is operationable, meaning that you have data that is available that you can use in order to compute metrics and to use these metrics to make assessment on quality of the upper parts of the quality model. So this is the general idea. And this general idea can be visualized in the following picture. So you have on the top level the business value that is more related to the characteristics of quality, and on the low level the data availability that is more related to the metrics. For instance, you may have as a business value, and using again the ISO jargon, an attribute that could be code complexity. Of course, this attribute is not the real thing for the stakeholders, because this code complexity could be related to some characteristic. I will come back later in a couple of slides to this. And then on data availability, you may have some data sources, like for instance, SonarQube. From these data sources, you may identify which are the raw metrics that influence in this attribute. And for instance, you may have a raw metric that is the cyclomatic complexity of a particular function or method in your code. But of course, this metric is a raw metric, and you need to calibrate, or better said, you need to normalize it in order to influence this attribute in a well-controlled way. For instance, if you have another raw metric that is the number of commits that you measure in GitHub, how can these two raw metrics put together when computing an attribute? For this, QAMOCO proposes the concept of normalized metric, so that any raw metric has to be normalized in a 0 to 1 value using some size metric. For instance, if we have a raw metric function cyclomatic complexity, the size metric can be the number of functions in the code, so that the normalized metric is the average cyclomatic complexity. So this is the general picture of QAMOCO. Concepts are not difficult and are very well known, and maybe the merit is that they are put all together in a simple way and that they can be made operational. Of course, then, this arrow here from metrics to attributes is a first thing that we need to understand. What is proposed in QAMOCO is the use of utility functions. If you are not aware about the concept, an utility is the strength of preference that a decision maker has among alternatives regarding a specific quality aspect. So these are the two types of utility functions that QAMOCO is considering. They are restricting to linear utility functions because we could have arbitrary and more difficult to handle utility functions, precisely because if they allow arbitrary utility functions, they be more difficult to combine, and they argue that linear utility functions from the projects, they know that behave well enough. They propose this use, and we have the two types, min-match and match-min utility functions, depending on the slope of the function itself. And of course, the difficult thing here is to understand which are the minimum and maximum values that define the utility function, and from that, the slope is automatically defined. They do not have a magic formula, and the proposal they make is that we need some benchmarking in order to understand which are the appropriate thresholds for these quality values. Once we have, again, in this picture, the attributes, recognizing the hierarchy that is behind the quality models, we need to combine these attributes into more complicated attributes. And for that, QAMOCO is proposing the use of weighted sums, again, using existing data or expert opinion in order to form the weights. So for instance, code complexity can be weighted with one weight, coupling degree with another weight, and both together can be combined to know about code modifiability, and so on and so forth. We can go up to the highest levels, in which QAMOCO proposes to use qualitative scales, in particular, either ratio to ordinal, they transform from ratio to ordinal in order to give an interpretation to the values. Of course, if you have a 0.7, you want to know if this 0.7 is good or bad. So again, they use some combination functions that aggregate these ratio values that come from the numerical attributes to understand the subcharacteristics rate, using some analysis, for instance, with school grades. So this is one particular way. I'm not particularly advocating for this one, but this is one way in which we can customize a particular quality model, a domain quality model into a particular quality model. Just to give you a glimpse of how we are using a similar approach into our QRapids project that Barry presented when introducing me, and I also mentioned it in the outline. I'm using 3 or 4 slides to contextualize the use of this approach into the QRapids the QRapids European project. What is QRapids in 1 minute? What QRapids tries to do is to suggest to decision makers quality requirements that may help to achieve the wanted thresholds of quality for different aspects. It is a data-driven project, meaning that from the running system or development repositories that we have for our project, we gather some data, analyze some data. From this analysis of data and some knowledge base that we have, some candidate requirements can be proposed to the decision maker. This decision maker can undertake a strategic analysis so that the impact of considering or not considering these quality requirements into some key indicators is understood. What is a key indicator? For instance, product quality, for instance, team performance, for instance, risk. If we establish this link between the quality requirements and these indicators, and we present all of this through a dashboard to the decision maker, our hypothesis is that the decision maker makes better decisions related to quality. And at the end, from this decision-making project, some of these quality requirements are selected, scheduled into some release, and then go to the backlog for later cycles of the system. So this is the general conception of QRapids. This more abstract view is somehow operationalized into this more concrete view. It is the same cycle, so I will not enter into much details, but it is important to see that we have several types of data, both from the end user, meaning the usage of the system and the quality of service, and from repositories. We're considering software repositories, but also project repositories. Details can be found in this reference that is given in the slide. And we are using Cuamoco, this Cuamoco approach in QRapid, so that this is a, let's say, somehow beautified version of my former slide, applied to one particular case that we are using in one particular project in QRapid from one of other industry partners. This is again described in some reference that I'm giving in the slide. And basically it works. Here, the main, let's say the main task when we need to put this into work for a new project or a new company is to develop the low-level connectors to the data repositories so that the data can be effectively gathered. Every company uses their own repositories, they use their own metadata schemas, so it's quite necessary to provide these connectors ad hoc, and this propagates up to the quality model and closes the view that I have given before. This slide just gives detail about what I have said before. We have a lot of repositories, Jira, Gerrit, proprietary tools, SVN, Jenkins, and we need to develop the code connectors specific for all of them. It is also good to mention that the use of ontologies in QRapid goes a bit beyond what I have said. So it is not just ontologies for the quality aspects, but also we are using an ontology for integrating all these diverse data sources that we have in this slide. So at the end, we have an ontology that defines what the concept of release, the concept of code version, the concept of commit, the concept of documentation. And this is defined in a way that the different sources can be integrated more easily, even if we have to develop the connectors by ourselves in an ad hoc manner, then the combination is easy. Okay, I have another example of application, but I will skip this one. As I was mentioning in the outline, I knew that probably I would make short of time, so I will simply explain in 1 minute what is the example that I had prepared that expresses another use of ontologies that we have experienced in our projects. We have used ontologies in the construction and management and utilization of a software requirement pattern catalog. So in this figure, I summarize the view, how we can construct a software requirement catalog using an ontology with two purposes. First, the ontology is defining the structure of a software quality pattern, a software requirement pattern, sorry, so that the different parts that compose a software requirement pattern are very precisely defined. This is something that we also experienced in our work when we started to work in this domain, that there were several proposals, but they were using different concepts and different ontologies, implicit ontologies usually, to represent this concept. So our first contribution was to consolidate these different approaches into one ontology. And then what we also do is to use this ontology-based approach to quality models in order to classify the patterns that are in the catalog, so that we have the catalog in a flat form, and then different classification schemas, different ontologies provide a structure over the catalog. I just refer to this reference that I have included in slide 41 if you want more details, and of course for this and any other thing, please feel free to contact. And then in the last 5 minutes, since we started around 10 minutes late, I will try also to finalize, to leave 5 minutes for the question. As I said at the beginning, we have two components that retrofit one to each other. First is the ontology itself, and second is the formalism or the language that is used to express the ontology. And we may find several approaches. Some approaches are using variations of the W3C standards to express ontologies, like OWL, RFDIF, SparkQL, that are different languages that provide different views of this ontology work. Even we can consider XML with a lightweight perspective again. Then we have more formal views like description logics and the first order logic. Then on the other side of the spectrum, we may have conceptual views like UML or entity relationship models. And then quite frequently we find ad hoc approaches. All of these formalisms are in place. We have different proposals using one or another, and they have their own advantages and inconveniences that are quite normal for this type of variation. The more formal, the more you can reason about, the more difficult it is to use. If we talk about our community on requirements and non-functional requirements in particular, there is a quite well-established approach that has several variations, but the main root is one. It is the NFR Framework that was delivered in year 2000 after some years of, let's say, work. And you may know probably the approach, and it is summarized in a book that is quite popular in the field. I may skip the explanations and go direct to the main constructs of the language. What can be done with that language? Basically, to deal with quality, the main concept is the concept of NFR Soft Goal. A soft goal is a goal whose satisfaction is subject to opinion. So, to give a very naive example, if I say the system must be quick, my concept of quick may be different to your concept of quick. So this is a soft goal, but of course soft goals can be a good point to start, but we need at the end to provide them in a way in which they can really check. And this is the concept of operationalized soft goals. So initial soft goals are elaborated into a tree until they become operationalized. And the notation is providing some relationships, some links between these goals that allow to state synergies, conflicts, and contradictions between these soft goals. At the end, we end up with the so-called interdependency graph. And this is the way in which a project using the NFR framework expresses the final state of the software quality, starting from the initial goals, ending to the operationalization. What is interesting, if you see these symbols inside the clouds, is that this approach has a reasoning engine that allows to inquire whether the goals are satisfied given some assignment of values to the leaves. So that I can explore if validate access against eligibility rules is not fulfilled, what are the consequences on the achievement of the rest of goals. Therefore, with several contribution links that I have in this network, I can really explore what are the consequences of decisions. So the evaluation engine that they have provided for this notation is based on rules like these ones. That these are a couple of examples that I have just selected from the engine. So for instance, if you have here an order composition and you have, an AND decomposition, and you have two leaves that are fulfilled and the parent is fulfilled, but of course in an AND decomposition, if one of the goals is not fulfilled, the parent is not fulfilled. And we have some bottom-up propagation for this. This is the trivial case, but then we have a more complicated cases, because when one goal is contributing to another, the degree of contribution can influence on the degree of achievement of the goal. So they have provided a very well-defined and well-validated approach to know what are the values that can be behind this evaluation. Okay, and I know that this last part has been a bit fast, but at least I completed my talk. As a kind of summary, if I can provide you with just 4 pictures, this is the situation that we are experiencing in many contexts about software quality. We have a Tower of Babel that is damaging ourselves in order to get a good understanding and a good management of quality. To fight against this torrent of Babel, what I was proposing, or what I was presenting, not proposing, of course, is the use of ontologies, so that with ontologies we can agree on which are the fundamental concepts and what are the precise meaning that allow us to fight against this diversity. But I also gave very clear the idea that no, one size does not fit all, and that even working with ontologies, we cannot aim to have really universal ontologies, but we need to reach dedicated agreements in order to allow diversity. And I provided an overview of how we could make this tailoring, how we can make a custom-made quality model from the general purpose ontology-based domain models. This is the main summary of my talk, and with that, I would like to conclude, and thank you very much for your attention.
Well, thank you very much for your presentation indeed. Do we have any questions?
No, I actually don't see any questions in, so if anybody does have any, feel free to submit them. Steve Dam just mentioned on slide 27 about the legend, maybe needing a legend for the Y plus and Y section of, it was slide 27. But other than that, it's just appreciations of the presentation.
Yeah, I got a question privately through the chat, so maybe I can read it and I can give the answer to this question.
Oh, excellent.
Yeah, so the question is, how can a quality ontology be a shared conceptualization when there are so many proposals and such poor overall understanding of software qualities? This is, in fact, this is the main point, and I think that the summary slide is somehow trying to answer this. The meaning of shared, and in the question that I received, this shared is quoted. I mean, it is between 2 quotes, because of course, and I think that this is the key, who is sharing? My main message is that I think that we cannot realistically expect to have a universally shared ontology among a community that is too wide. When the community starts to be too large and too wide, agreements are more and more difficult. And we all know that. I mean, and the ISO 25010 standard is a clear example. I think that no one of us is happy with this standard, even if most of us use it at some extent. Why do we use it? Because it is a kind of lingua franca. Even if we are not really happy with it, it is something that is more or less widespread. For some of the concepts, we can agree. So at the end, we want to rely on something that is shared among all the community. But on the other hand, when we go into the details is when we have the problems. So this is why when I said that we cannot aim to have very large agreements, I'm meaning precisely that. When I said shared understanding, it needs to be by a community that has a common vocabulary, that has a common background, and that is aiming for similar goals. In this example of the web services that I gave, if you take a look to the paper, you will see that we finalized in a first level of the composition of the subcharacteristics, which is very, very, very few. And we did that after overall consolidation of a lot of words that exist in the market. We didn't want to provide metrics. We didn't want to decompose these attributes. Why? Because probably this is work that is useless, because a particular project will refine otherwise. So that was my answer. I got in the middle, again privately, in the middle of the response, I got another question, if I can read. Do I have 1 more minute, Mimi, Barbara?
Sure.
Yeah, okay. Well, it's not okay. It's not a question. It's just a comment that I can read because it may be also of general interest. You may want to look at the lifecycle modeling language ontology as a starting point at the system level. You can check it out at the lifecyclemodeling.org. And okay, I know this modeling language, and I would say that the situation is a bit similar. Without going into the details, again, we have this situation in which it is a very general purpose proposal that is good as a starting point, but again, the table is into the details. And also, and last, another comment from the first person that made the question. I understand that if he's talking to me privately, I respect the privacy. The person is making just a comment, a follow-up of my answer. Pure taxonomical arrangements are insufficient to accurate related qualities. Completely agree, completely agree. And I mentioned that ontologies have this third component that are the properties between the concepts. And in fact, this example of the NFR framework is showing, maybe I went too fast, but if I go back just 1 second, oh, sorry, here, for instance, these minus and plus signs are not taxonomical relationships. They are properties that are cross-cutting the taxonomic relationships. So it is something that I completely agree, and this is something that the community that works with ontology knows and tries to let's say, deal on different matters, like for instance with this type of construct. And that's all. I do not see any other comment or answer, so thank you very much again.
Xavier, one more question.
Yes?
If you look at response time, some ontologies say that it is a function of workload, and but how do you accommodate sources of variation in the values?
Can you repeat the question, please? I lost the beginning.
Yeah. Some ontologies include sources of variation in the value of the quality. So response time is a function of workload, for example.
Okay. Yeah, this is I mean, this is another dimension. Okay, there are like two different things in this question. On the one hand side, if in one, I mean, what you say, for instance, for system engineering and for the type of systems like life critical or response time is really important. If this concept of variation or implication, I mean, something that happens in a particular context is important, then the ontology needs to reflect that. So you need to introduce a concept like, for instance, the concept of context, and then you may have a relationship in these properties between the concept of context and the quality attribute that you are measuring. So from the ontology point of view, this is a very good example that says that you need to customize the ontology to every particular domain that can be, let's say, demanding in one direction of quality. This has nothing to do about the practical issue. I mean, if I go to this Cuomoco approach and then I talk about how to operationalize all the requirements and what are the data sources, of course, if you have this context, this becomes more and more and more complicated. But we know that. We know independently, this is not related to the ontological approach. This is related to software quality is inherently difficult. And if you have something that is difficult to measure, it will be difficult, no matter if you use ontologies or you don't use them.
Okay, good. Well, I think that's good enough to wind us up. And again, thanks very much for giving us a guided tour through all the various options for ontologies and qualities and the like. So thanks again. I think we'll wind up here. Anything else, Mimi?
Nope, just that in 2019 we'll be releasing our schedule for the next SERC talks soon. So as soon as we do the wrap-up follow-up email for this, we'll note those dates for you for 2019. And thanks again for joining us, and thanks again, Xavier, for your presentation.
Thank you very much for inviting me, and I really enjoyed to have the opportunity to make this talk. And just feel free, in the first slide of my presentation, you have my email address. Feel free to contact me for any follow-up questions. Thanks so much. Bye-bye.
Okay.
Thank you.
Bye, everybody.
Bye. Have a great year. Happy holidays, everyone.